1.
All right, in the previous problem we did, we said that the function was 2 times x, and let's get rid of that. And we found the derivative was 2. Maybe you'll see a pattern. All right, so let's look at a different one here. Let's put a 3 here, and let's add a constant. We'll add 1. Right, we'll add 1. So we have f of x is equal to 3x plus 1, and we're going to want to find f prime of x. Now, using the definition. Now, of course, I'm using f. F is a little overrated, I'd have to say. We could be calling our function anything. This could be g, h, could be a name, who knows. You can write anything you want here. All right. All right, so the goal is to find what is f prime of x using the definition. And of course, we have to say as long as that limit exists. All right. Okay. So the first thing I'm going to want to do here is I'm going to go ahead and I'm going to want to find this so we can plug this into our formula. We want to find f of x plus delta x. All right, that's the very first thing that we want to find. So remember, x plus delta x gets substituted in right here for this x. All right, so that's the very first thing we want to find. F of x plus delta x. Wish there was a shortcut key for this delta sign. Delta x, all right, is equal to 3 times, and instead of me writing all that in, I'm just going to copy paste it here. Right, make life a little easier on me. Okay, and then of course we have plus 1. So what we'll want to do here is go ahead and distribute this 3. Go ahead and distribute the 3 across. Okay, so that's what we'll want to do. And I think we'll just copy paste this whole thing. I think I could hit select all somehow on that. All right. Okay, so that means we're just going to knock that down. So we have 3x plus 3 delta x. Go ahead and get rid of that. All right. So as you can see, that 3x plus 3 delta x plus 1 is going to be going in right up here. Right. It's going to be going in right here where this is located. Okay. See that? All right. Which means that we're going to go ahead, highlight all that, move on down. Okay. All right. And okay, so you should be able to keep up with what's going on here. Hopefully, probably write it out faster than I am. I've kind of chosen to do it this way. Instead of writing on a tablet, it just seems like there is no mistake on what's being written on the screen here. So we have 3x plus 3 delta x plus 1 minus f of x. Now remember what our f of x is, and you must start a parentheses on this one. Always put a parentheses around your function. If you don't, you're going to end up getting this thing wrong because you see this minus sign right here. Pretend that's like a -1 right here, and you need to go ahead and distribute that across inside. Okay, even though the 1 is not written in. All right. So once we do that, this negative sign here needs to get distributed across. Okay. So it's a common mistake. It can easily be made. Let me tell you. I mean, I still make plenty of mistakes, and I've been doing this stuff for years. All right, let's go ahead and take that down. Okay. All right, now what we can do here is we can go ahead and simplify this thing down. And of course, what I'm going to do um, is Control A. No. Trying to remember. Whoops. I didn't want to do that either. That select all didn't do what I wanted it to do. Okay, we're just going to go ahead and do it this way. Okay, so let's go ahead up here in the numerator. And so we have that -1, we have a +1, so those are going to disappear. And also that -3x, and we have a +3x. So you see that's going to disappear also. Subtracting off the function. Now, as you can see here, we have a 3 delta x and then a delta x down in the denominator. So the delta x's are going to cancel out. Okay, the delta x's will cancel out. So, you know, majority of the time when we're doing calculus, we end up spending most of our time just doing algebra, doing intermediate algebra. I mean, that's what we spend most of our time doing. Okay, so because the 2 delta x is canceled out, right, this delta x and this delta x is going to cancel out, we're just going to be left with 3. So the limit is delta x once we simplify this thing down. And so once again, we have the limit of a constant, and the limit of the constant is just the constant, which is actually 3. So what could we say up here? Well, we could say that f prime of x is equal to 3. Right, so hopefully at some point here, you'll start seeing a pattern, maybe of some kind. And of course, when we actually get to the rules of differentiation, we won't be going through all of this. Right? Okay, they got to drag you through the mud first. And actually, instead of, it's called the eliminating students out of the class. Yeah. If not everybody on the planet would be an engineer, if calculus was easy. I know, isn't that crazy? Okay, so that takes care of that, and we'll work 3 more problems on this.